Hello class, God bless you. Class, today I am with lesson number 3 from chapter number 3. And the topic of today's lesson is shielding effect and its trend. Ionization energy and its trend. We are talking about the periodicity of properties in a periodic table. So, why properties are repeating them after a certain interval? Today we will know that what is shielding effect and ionization energy and why their values change across a period and in a group. So here we begin with the shielding effect. The shielding effect is defined as the decrease in attraction between an electron and the nucleus in any atom. We know that atom is a composite of two oppositely charged bodies. Electrons, negative charge, moving in circular orbits, but protons are positively charged and they reside in the central part of the atom in nucleus. Now, what is shielding effect? We know that oppositely charged bodies attract each other. And the shielding effect is the decrease in the attraction between an electron and nucleus of any atom. Means the effect of the proton from the center of the atom on the revolving electron. Why this effect is decreased? Now we will understand with another picture that suppose this is nucleus in which positive charge is concentrated or in a high density, and electrons are spread around the nucleus in different orbits. Now suppose these electrons are very much attracted by the nucleus because they are closer to nucleus. But what about these electrons? They are coming in the second shell. So as these electrons are attracted by the nucleus, they come closer to nucleus, means decreasing the size of the atom. But at the same time, these electrons are repelled by the inner shell electrons, like this electron repel this electron. Similarly, the outermost orbit electrons are being repelled by the inner ones. So if outermost electron tries to come closer to the nuclei, the inner shell electrons repel them outwards. So shielding effects means the decrease in the force of attraction. Now there are few points which need to be cleared. We know that electrons are attracted by the nucleus and electrons repel electrons because they are having same charge, and outer electrons are repelled by the inner electrons, and as a resultant, outermost electrons get less attraction from the nucleus. This is the definition of shielding effect. Now we see what is that factor on which shielding effect depends. The answer is atomic number. Means more atomic number, more shielding effect. How come they are related? Because atomic number means the number of protons in the nucleus, but at the same time, for a neutral atom, the number of protons are equal to the number of electrons. Means more atomic number, more electrons in their shell. So the shielding effect is dependent on clearly atomic number. Now first we will revise the trend of atomic size. That we know that going down a group, atoms are experiencing in the increase in size, but moving in a same period, atoms are getting smaller in size, means the atomic size is decreasing. Now we see the shielding effect is also related to the atomic number. As we go down in a group, the number of protons is increasing. Similarly, atoms are getting bigger and more electrons are present. For example, for alkali metals, hydrogen is sitting at the top of the group. Hydrogen has only one electron in first orbit, like this. But the next element of the same group, alkali metal, is lithium. Lithium has 3 electrons but in 2 shells now. What about the shell outermost? What about the electron which is present in the outermost shell? Maybe if I draw the structure a bit bigger, this is nucleus, this is first electron, and the second shell has 1 electron. As the electron is feeling attracted by the nucleus, this electron will repel this electron outwards. So here the shielding effect is increasing. Going down the group, we are seeing that for a sodium atom, more electrons are present in its atom and number of shell is 3. And for potassium, 4 shells are present. So as the more electrons are present in their orbits, the atom is getting larger in size. The shielding effect or the repelling force of the innermost electron is also augmenting or increasing. But the shielding effect remains the same as the elements move in a period. Now the final trend, shielding effect, increases down a group and remains the same in the period. The next property is ionization energy. In very simple words, ionization energy is the energy required to remove an electron from a gaseous atom or ion. So here we are trying to understand what is going on at the atomic level. Like this is an atom having electrons in its orbits and protons in its nucleus. Means on providing energy, electron can be lost out by the atom and the neutral atom will be positively charged. So the amount of energy which is required to remove or to knock out the electron from a gaseous atom, means a neutral atom or an ion, is called as ionization energy. Now what about first ionization energy? The first or initial ionization energy of an atom or a molecule is the energy to remove 1 electron from a gaseous atom. Suppose if magnesium atom has 2 electrons in its outermost shell, on providing energy it will be making its cation and making positive ion. But on providing much more energy, magnesium positive ion will be knocking out its second outermost electron and 2 positive charges will arise. So this is how it is possible that one element can knock out 1, 2 or 3 electrons. Now ionization energy depends on the size of the atom. Why this is so? Like the atoms are getting larger down the group and they are shrinking in size in a period. Now as the atom gets larger, like this much, the outermost electrons are very least attracted by the nucleus. So to remove the outermost electron from a larger size atom, is very easy as compared to the atom which is smaller in size like lithium. So to knock out electron from a cesium atom is much more easier than lithium. So ionization energy is also decreasing down the group. Now what's next? Okay, this is a periodic table showing the value of ionization energy. It's decreasing down the group and it's increasing in a period. Now this is all about today's lesson. Just listen the lesson again and again and read the topic thoroughly from the book. Then you make your own trends of the properties from the periodic table. Okay class, thank you. Take care.